So in this presentation, I'm going to present maximum spatial perturbation consistency for unpaired image-to-image translation. So in the unsupervised image-to-image translation, we aim to train an image translation model on unpaired source and target domains, which is an ill-posed problem, as an infinite number of translation functions can map the source domain distribution to a target distribution. Therefore, much effort has been put into designing feasible constraints. One of the most popular methods is cycle-GAN, which enforces the cyclic reconstruction consistency. However, cycle-GAN assumes that the relationship between a source and target is bijection, which is limited for most real-life applications of one-to-many and many-to-one mappings. GC-GAN proposes less restrictive constraint on output by simple spatial consistency. However, the model would easily overfit this kind of simple pattern. Latterly, CUT enforces strong correlation between the input and translated images via patch-level constructive learning. However, it is restricted to less flexible translations. To augment the unsupervised image-to-image translator, we propose an adversary training framework, which is maximum spatial perturbation consistency. Here we denote the image style translator as a G, and our differentiable spatial transformer as T, which is image specific. To construct consistency under spatial perturbation, we transfer the translated image GX with the learned spatial transformation as TGX. And for the spatial transfer image TX, we feed it into a translator G, later as GTX. In the end, we aim to minimize the L1 difference between TGX and GTX. To be notified, we learn the T against the G adversarially. For our second proposal module, we try to achieve pre-alignment between source and target data. So we denote distribution of the source images as PX and the target distribution as PY. So there is a noticeable distribution gap between source and target in the sense of spatial site and object location. Our method is able to generate a new source and target domains after spatial transformation, which are PTX and PTY. As we can see in the figure, the distribution gap between PTX and PTY are narrowed down with respect to spatial site and location. In our experiment, we quantitatively and qualitatively show the effectiveness of our MSPC on addressing inconsistent content and unstable state transfer. For the unpaired selfie to animate experiment, we found cycle-GAN, GC-GAN, and CUT would evolve unrelated features. For example, the hairstyle and the face contour are mismatched with the input. In our model, the content are kept without distortion. Another issue is that these models would easily fall off unstable training when the source domain and the target domain have big style gap. In our constructed from face to profile face task, cycle-GAN, GC-GAN, and CUT result in early model collapse during the training time. And our model successfully translates the input to a target style without changing the identity. One way to quantitatively evaluate the quality of the result is using FID, and it shows our method is more powerful in distribution matching. Thank you. For more detailed implementation, our GitHub repo is posted.